Yes, sir, please.
Hi, good morning. I'm Khalil Sheikh, EVP of Solutions at Sexton Global. Sexton is a data management and analytics company that helps organizations become more insightful and gain a competitive advantage by having access to actionable business information to make real-time decision making. And with me today is James Serra, and James is an industry veteran in the data management space. Today, we'll be talking about alphabet soup of data architecture, which include modern data warehouse, data lake, differences between data mesh and data fabrics, as well as we'll talk about how does AI play a role in today's business intelligence. Let's get started. Welcome, James.
Thanks for having me. I like the term industry veteran except instead of this old guy here. So I've been in industry 35 years now. And just quick intro, I'm a data platform architect lead at EY. I've been here for about 6 months. And before that, I was at Microsoft for 7 years in pre-sales technology focused. And before that, I have a long history of being a DBA and a consultant and building a lot of data warehouse and database solutions over many, many years.
Thank you, James. So we'll get started. James, my first question is, how do you see the modern EDW versus data lake? And how do you see the cloud playing a role into the today's data warehouses and data lake?
Yeah, sure. It's interesting how things have changed over time. And it used to be everybody had a data warehouse. It was a relational database, and that worked great for many years. It scaled, and especially when they got into MPP technology, multiple parallel processing, and things like Matisse and Teradata and such were able to handle big data. And then over time, when the internet came around, there was a lot of different types of data, and big data definition was completely reworked to be a lot higher scale than we've seen previously. It also came into play different types of data, structured and semi-structured and unstructured data. And so it was very challenging for companies to ingest all this data and transform it and make better business decisions by putting it in a format that's easy to use. And so this is where the data lake concept came out. And the idea is I can land it all in the data lake, and it's schema on read, meaning it's very easy to land the data in there and then put compute on top of that and transform that data. And we can do a lot of analytics and machine learning. We can build a lot of machine learning models and do a lot of predictive analytics on that data as it sits in the data lake, but also move it to a relational database because of some additional functionality and features you get out of a relational database, such as performance. If you need a faster performance compared to a data lake, security is another one. And being on schema and write means it takes more time to put the data in there because you've got to do more upfront work, but it also match the metadata with the data. So this means it's a lot easier for end users to go and query that data as opposed to having this file sitting in the data lake. And it was really interesting too when the data lake came around about 10 years ago that people thought we don't need relational databases anymore. This was this great place where we have rainbows and unicorns and we can land data in there and it automatically pops out and it's just what we need. But when I was working for Microsoft at the time, I saw many companies completely fail when they tried to use just the data lake and replace their relational databases. So then it became popular to have both a data lake and a relational database. And there are many reasons for using a data lake. And I'll just pop up some of those reasons on this deck that I have, which we'll make available for everybody to view. Oh, I'm disabled from me doing screen sharing. If you want to change that, I can do screen sharing. Otherwise, I'll just talk through a couple of things that relate to creating a data lake. One of them is, if you can think of the problem you had with the relational database when you're ingesting all this data was to clean the data meant you have to have a maintenance window. And I'm going to knock people off the system. I'm going to land the data. I'm going to transform it all, and then I'll invite people back on, which was very challenging, especially when a database, you wanted it up in 24/7 in there, or something happened with your maintenance window, overran it and such. And so the data lake came out. It's just one big reason was just to use it as that area where you can do all the transformations, that staging area. Instead of being a relational database, it was in the data lake. And that allowed you to do all those transformations outside of the database, not colliding with other users. And then you just had an extremely small maintenance window where you just loaded the data. So it may be a 7 or 8 hour maintenance window would go down just a few minutes. So that was a big reason to use the data lake along with relational database. And there's also be much more cost effective compared to using the compute on a relational database. It also can allow you to separation of the data and the compute meant I can fire up a massive amount of compute I want, much more than you get in a relational database. So if I'm willing to spend the extra money, I can fire up all these clusters of compute and run it on that data lake. And the idea is have the best of both worlds, where you can do things on the data lake for reporting, but also do it in the data warehouse for additional features of security that I mentioned before. So that is where we got into the modern data warehouse of using the data lake and a relational database.
Excellent. Thank you, James. There's a lot of confusion in the enterprises right now around data mesh versus data fabric. What is the value? How does enterprise can make best use of it? How do you describe it based on your experience? How do they differentiate, and what is the value an organization enterprise can get out of it?
Yeah, there's so many buzzwords going around now, and it's almost comical in that a lot of these buzzwords are not new technologies, or not new ways of doing things, or just a cool name like a data mesh to put on technologies that we've had for quite some time. When I talk to customers and inside internal UI and explain all these buzzwords, what I say is think of what I just explained was the modern data warehouse. And if we want to go and add additional features to that modern data warehouse, and some of those features are defining how they're going to access the data, some data policies. We get into, or we can use RBAC and ABAC. When we want to create a metadata catalog, when we want to use master data management, we want to use maybe data virtualization. Maybe we want to build things such that we have building blocks that can be reused by other applications. As you add all the additional features on there, that's when it becomes a data fabric, when it has a lot more ability to pull in much more types of data and transform it and clean it and master all these things. So I think I view data fabric as a sort of a glorified modern data warehouse on there. Now, I'll have to say that this doesn't mean my answer is completely right, and there's different takes on what all these buzzwords mean, but I'm trying to put it in context of what I've seen and what customers I talk to understand. So think of a data fabric as that kind of an evolution of a modern data warehouse. Now, the other buzzword that we hear is also the data lake house, the combination of a modern data warehouse and a data lake. And the idea, which came about through Databricks, was, well, maybe we don't need a relational database. Maybe we can add features to a data lake to make it do everything a relational database can do. And the feature that was put on top of the data lake for that to happen is called the Delta Lake. And Delta Lake adds additional features on a data lake, such as ACID compliance and a faster speed on there. And then they also have a thing called time travel, where you can have data versioning and you can do rollbacks and audit trails. And it has schema enforcement and upserts and deletes that you can now do on the data lake. And so this made it more relational database-like. And so some use cases are coming out where, okay, maybe we can now get away with just using a data lake and not have to have a relational database. And I don't think those use cases are as varied as some people believe, but I start seeing some instances, in particular when you look at some of the latest technologies that have come out. And for example, at Microsoft, they have Azure Synapse Analytics, which has a serverless pool, which allows you to query data sitting on a data lake. And it could be a Delta lake. And you only pay per query, and you put this, you can create a view on top of the data sitting in the data lake. So you give them metadata and make that available. So it seems to the end user they're actually querying a relational database, but it's really just a data lake. So some use cases now for that data lakehouse approach in there. Now, the other one is the data mesh. And this is more of a organizational change than just a technology change. And the idea with the data mesh is everything that I've been talking about is centralizing the data. It's copying it into one location. And that has its challenges on there. One of that being, well, who owns the data? If I copy it into the central location, is it IT now owning it, or is it still the various domains that are feeding the data on there? So the idea of the data mesh is instead of centralizing the data, you keep it within all these domains in there. So maybe you have an HR and a payroll and some operational data. And all of those, what we call domains, we think of them as data as a product. They each own that data, and they take that data and create an analytical portion of that data for their own needs. And therefore, it makes it easier to scale because now each of those teams are responsible for creating their data in an analytical format, and instead of central IT being the bottleneck in there. Now, what central IT does is provide what you can call a data infrastructure or platform. It will give some governance over all that data. It will ask each of those domains to follow some contract for how are they going to clean and transform and master and security-wise handle all that data on there. And so now you have this mesh of all these domains in there handling their own data. And if somebody needed to combine the data from multiple domains, then that's where it gets challenging, is they would have to then pull all this data out of each of these domains, combine it, and get the queries and reporting that they're looking to do in there. So there's some great ideas, at least in theory, on how the data mesh can help on there by having a decentral environment, by having less ETL of copying to a central location, by using data as a product. And then each of those domains have their own engineering teams, so they are much able to scale out. And this is where data mesh comes into play. Now, there are many challenges with the data mesh I can go into, and it's only for specific use cases where you're a company that has a lot of data, a lot of domains. If you just have a handful of domains, because data mesh requires a lot of upfront work and a lot of organizational change, it would be overkill. So if you're a very big company, then you can possibly make the case for a data mesh. And this is by far the biggest buzzword I'm seeing lately. And I'm trying to educate people through presentations like this to talk about the differences between all these different buzzwords. And then maybe you can have more guidance on what is the best for your particular situation in your company.
Thank you, James. What do you see the maturity level for the organization for selecting one versus the other? And how do you see that it's not for everybody, right? You have to be a fairly large size organization where the complexity of the data, maybe having multiple acquisitions and all. Where do you see, is there a maturity model if an organization wants to do an assessment that they want to go beyond their existing data warehouse and data lake that is sort of like limited in its capacity? Is there a way to assess, is there a maturity model existing today? And what size organization it should be in order to even think through this, this complexity?
Yeah, I wish there was a great flowchart or some assessment tool that you can plug in a few numbers and it will tell you what's the best solution. And it's interesting because a lot of it is questions I ask a customer to help me guide them into the right architecture for them to use. One of them is, what is your current skill sets? And if you focus all your team on mainly a handful of skill sets, and I'm going to propose an architecture that's going to fit best for your current skill set, unless you're willing to spend a lot of time to train everybody in some other skill set in there. And so you have to ask other questions like how much data is it? What's the size, the speed, the type of the data? Do you have real-time data coming in? Is a big one. Streaming data. What's the end goal? And that's the biggest thing to ask. And what are you trying to accomplish here? What is it? Is it some dashboard reports, machine learning? And let's work backwards from that. So you tell me what you need. And sometimes that involves presenting to the customer possible technologies that they're not aware of, because you don't know what you don't know. So if you all you do is things in Excel spreadsheets, and I ask you what would you like, it's going to be some variations on the Excel spreadsheet. But then you go and show somebody Power BI or machine learning they've never seen it before, and their minds become blown. And they go, wow, I didn't think this was possible. And then you start brainstorming of different ways of taking this data and making it available to make those better business decisions, to get more insights into your company on there. So there's a whole list of questions, and it'll be in the deck that I send out. You can see some of those questions I usually ask. And then that's going to guide me. And so I would spend time with customers the whole day just whiteboarding and drawing out some of these concepts before I even put products to it. It's just let's talk about if a data lake and relational database is appropriate for you, and how much data is it? And because then you got to think of other things like, well, if there's a lot of data and it's on-prem, how am I going to get it to the cloud? Do I have the pipeline to do that in there? How often do I need to update the data? Can I break it up in little chunks during the day? Those kind of things. But what we find, and for a lot of companies, when I talk about a data maturity stages, I usually have 4 stages in there. One of them is the stage 1 is just kind of you're reactive. You're just trying to get this data and you're locally managing it. And now you have all these independent silos. So that's the big problem in there. So the next stage, and where most companies are at, is you're trying to centralize all this data, whether they put it in a data lake, whether it's on-prem in the cloud, although almost everybody's on the cloud now, is let's just gather it all in one location. And that will help us when we have this mirror look on there, is we want to make decisions based on what's already happened, historical trends that we've seen, some patterns. The next stage 3, is where we want to do predictive analytics. We want to be able to take that data, but do advanced analytics on it. So we want to start doing machine learning on there and AI and do predictive analytics. So not just see where we've been, but where we're going. Can we predict things like when a part's going to fail or when we're going to lose a customer, and take proactive action instead of reactive action. And then we get to stage 4, where it's transformative stage, where we're trying to, and if you talk about digital transformation, this is the stages in there. We're trying to be able to build a solution where we can take any data, no matter the size, the speed, or the type, and scale it up in there and do that historical and that real and predictive analytics on that data to drive those outcomes that we're looking for in there. And that gets into just building a solution that's going to last for a number of years by spending a lot of time up front to understand what our data needs are going to be and the data we got out there. And it's a long journey, and it never ends, and you're always thinking of better ways to do it. And typically, in the solutions I've built with customers, once you give them that first taste of new reports and dashboards that they can do, they just go crazy and they want more and more in there, because they didn't know the art of the possible when you're showing them that. And then all of a sudden they want more and more data, and then you have a big pipeline of trying to fulfill all their needs and requests, which can be challenging. But that's great, because you wind up building solutions that can save companies millions of dollars by having that predictive analytics in addition to the historical reporting that they've had in the past.
Thank you, James. So how do you see what are the challenges? Because let's say, even if you have a modern data warehouse and data lake, and even you put a data fabric across third-party solutions and all, what are the biggest challenges that you see in enterprises when it comes to predictive analytics or actionable insights, or for that matter, even big data analytics, right? Where do you see the challenges are? Because everybody wants this actionable, role-based insight that they can act upon, right? Based on their their definition of business intelligence or letter of business intelligence. Where do you see the gaps are? Even if you have this magic wand where you have built all these data fabrics, um, how many organizations are able to meet that challenge? Number one. Number two is, what is the outcome out of it? What is the percentage of organizations that are able to meet that?
Yeah, I sometimes will joke with customers that go to eBay and try to find that magic wand, because that'll be the best way to build a solution in there. Because the challenge, I believe, is not so much in the technology. Now, there were many cases where I saw companies choose the wrong technology. You maybe all you know is SQL Server, and you try to build everything in SQL Server, and you go, well, why didn't you use some NoSQL solution like Cosmic DB? And they go, what is Cosmic DB? They have no idea. So I always felt, as my role as an architect at Microsoft, was to just make people be aware of all these products at a high level in their use cases, and that's what I use my blog for too. So you know all the tools available there. So you're much more likely to pick the right tool for what your particular use case. Where I've seen a lot of their projects fail, and having done this probably in data warehousing about 25 years of my 35 years in IT, it was the people in the process that it's challenging to find people who know this stuff really well, and that's why I would recommend consulting companies. If you're a big company, small company, medium-sized company, and you've never built anything like this, find people who've done it before. And find those experts who can guide you along, whether you want to have that consulting company do everything, or whether you want to just do staff aug and project planning in there. Because companies will fail when they don't realize the effort needed, especially when it comes to data governance. And that's the biggest challenge with customers. And when I see them and I put a project plan and they would only have a couple of weeks in there for data governance, I said, you need a lot more, because the data is not going to be clean when it comes in there. Yeah, it's going to be clean. And I'd say, I'll bet you I'll put $100 right down there. I'm going to find some problem with this data. And sure enough, when you pull it in a data warehouse, they go, oh, look, we have birth dates that show people are 200 years old, or they've just been born. And you find out there's all these loopholes that people found in the entry systems that allow them the data to get put in there when it shouldn't have. And now you've got to clean it. Well, you can tell them these are the loopholes and they'll fix it, but that doesn't help all the data that's sort of passed in there. So there's a lot of data governance. And then there's mastering of the data, MDM, when you have multiple customer data in there, and sometimes they're the same customer, and you need to merge them together and find those golden records. Because, and this is what I tell customers too, another important part to make it successful is work with your end users from the beginning. Have them part of the process in there. Make sure that they are given their input. So you're not just coming up with a solution and say, here it is, and you kind of shove it down their throat. Instead, they feel like they have some skin in the game by taking their input. And also, you can find mistakes and inaccuracies early on. Instead of what I've seen where it fails is customers will go and IT will go and build a solution, give a report to the customer, and then the customer looks at it and goes, well, wait a minute, why are these two people separate? They're actually the same people or company in there. And you didn't master this properly. And right away from the beginning, the first impression is they lost confidence in what you built. So that make them part of the process and spend a lot of time in governance early on to say, look, does this report look accurate? We're testing it out, let us know. So they feel like when it does come out that they are cheering for it, and instead of seeing it as something that's difficult to learn. And people hate change. And so you have to understand when you present a new way of generating reports and dashboards, even though it may be 100 times better, they're resistant to it. So get them on early in the process so they're not so resistant to it. Because there will be training, the new way of doing things, and people are reluctant to change. So you take those steps. And it was interesting at Microsoft, I spent a lot of time with customers, sometimes just talking about the way to lay out their teams in there, the different roles and responsibilities they have on there, because many weren't sure what to do. And again, a consultant company can help with this. But the idea is make sure you put the infrastructure in place with the people in the process, so at what you're building will be successful. And that could be maybe at a center of excellence, and maybe you put together these little teams that work on pulling in the data and understanding and learning the data. because I've been in meetings where it's almost come to a fist fight when people are deciding who owns the data, who's responsible for cleaning it all. So create those environments and those teams that avoids having a lot of those conflicts in there. So when you hear Gartner say 70% of technology fails, and it's not, a lot of times it's not the technology or the concepts, it's the people in the process. And that's why I say data mesh is not a silver bullet in there. It's not going to suddenly prevent all these projects from failing, because if anything, it may increase the ones that fail, because data mesh is a lot of work up front on there. And so it's a lot of organizational change. And so any concept you come up with is not going to be successful unless you put those right people and the processes in place.
It sounds like a lot of work, right? So people, process, communication, technology, all has to be coming together in order to build a good outcome-based delivery, right? So what do you think is the size of the organization should be? Because for small to mid-sized to large enterprises, like take Google's of the world or Facebook of the world, right? They may have the resources. Where do you
Yeah.
see that, what size organization is fit for, uh, as you describe, people, process, communication, and technology versus, uh, just to ad hoc based delivery, right?
Yeah, and it's interesting that the extremes at EY, I'm working on its data fabric, and there's a few hundred people involved in building this out. It's at a scale that I've never seen before, even inside Microsoft. And so there's its own challenges of that. And then there's these very small companies, maybe just a few hundred people, that are looking to pull data out of SAP and some other CRM system in there. And I think it goes back to what is your skill set and who is the people that are building this out. Do you have an IT team, or is each of the organizations trying to do their own thing? And this is where you get into the technology differences. And if you look at a product like Power BI, you can do everything in pretty much everything in Power BI. It could be a self-service ETL tool. So it can be used very easily by a power user to build a solution and get a quick win. And I've seen companies, smaller companies, just use Power BI for everything on there, because you can clean the data and do that transformation, land it in a data lake, and build a dashboard and reports off that. And it has automated ML. It's an amazing product on there. And you can never have to go outside of Power BI if you want. But you're not thinking about enterprise level. And so what I differentiate is, if you're a small company and you don't really have a enterprise, it's just a few hundred people in there, you can use something like Power BI and get something very quickly out of that. And it's always important, even if you get a larger company, you want quick wins. You don't want to have the old days with the waterfall approach where you go away for 6 to 12 months before you finally have something. But even at the larger companies, you can use Power BI to prototype, to get a quick win. And fortunately now you can reuse a lot of what you build in Power BI can then be moved to something like Azure Data Factory on there. So you're not wasting all that time. And I've seen the larger companies now go to the end users, instead of sitting them down and what's your requirements and documenting all that, they'll go, just build what you want in Power BI, a prototype, so we can see it firsthand and we can better understand what you're trying to do. And maybe we'll help you build it in Power BI. We can do something very quickly. And those become our business requirements on there. And so, and because I've dealt with so many times, you take the business requirements, you go back, you build it, you give the user, and they go, well, that's not what I meant, or that's not what I wanted. And you start over again there. So now that they're doing that, and we get a much clearer picture of what they're trying to accomplish on there. So as we get up to companies that are smaller than mid-size, then they may have their own IT department, and then they may want to use enterprise tools. So that's when, instead of using Power BI for ETL, they use something like Azure Data Factory. And then to store the data, they would use something like Azure Synapse Analytics on there. And then that's when you start investigating if they need outside help. And a lot of it depends on what's your timeline. I always ask, what's your timeline and what's your budget and what are your current skill sets? And those are the three main questions I have that would drive the approaches I take for a customer, because, and also there's a lot of cost savings now. I can come up and architect the best approach, and the customer may go, well, that's great, but we're willing to sacrifice some performance to save some costs. well, okay, let me come up with another architecture. And that happens almost all the time on there. So the smaller companies are going to be more cost conscious. So you may come up with other solutions that you wouldn't do for a large organization who has a larger budget. And it's hard to put on a chart of where all these lie. That's why I go and ask all those questions to a customer. And that guides me into what kind of solutions I architect out for them.
Thank you. And how do you see AI, ML recommendation engines feeding back to the systems of choice, right? How do you see that is playing out in this outcome-based visualization that is driving the competitive differentiation for the organization, right? How do you see AI playing into that role? And do you see that beside having operational dashboards, they're also feeding it back to the, their transactional system? How many organizations are doing it? How successful they are? What are the challenges associated with it?
Yeah, that's an interesting topic. And I feel like we're in early stages of AI machine learning kind of blossoming. Because in order to have if you think of machine learning, you have to train the model. To train the model, you need a lot of data. Very recently, most companies don't have that data to train the model. So we're getting to stage 2 where we're collecting the data, and that's where most companies are at. And once they collect all the data, then they can go, okay, let's get some data scientists. Let's think of ways that we can build these models and do more predictive analytics on the data now that we've got it all together. And so since there's a small percentage of companies who collect all the data, that means down the line coming, I think, a big wave of people using a lot more machine learning because they'll finally get to the point where that data is all collected and they can build those models on there. And that's where I see a huge amount of value. So when I talk to customers, I say, here's the icing on the cake. It's Power BI dashboards and reporting. Let me show you what those look like. And then machine learning. Let's brainstorm things you can do to increase your bottom line on there. Sometimes they've thought of these things, and then other times they have not. And at Microsoft, we would go around and show demos of all these products, usually related to their industry, and they would go, wow, I never really thought of that. Or we would tell them what their competitors are doing with machine learning, and they would go, oh, that's a great idea, we should do the same thing. So if you show that art of possible, you're getting the brainstorming sessions going where they can think of all the things they can do with that machine learning, with the predictive analytics on there. And then you have to go, well, that's the good news is you can do all that stuff. The bad news is we've got to collect all the data to do that. And if you're not at a point yet where you've done a lot of that, it's going to be a lot of work. But it's going to be huge payoff on there. And some of the machine learning models are just unbelievably accurate and how they can help improve that bottom line and save money, be more cost effective. And so I see a lot of interest in data science and finding the talent for that. And while the products have automated machine learning in them and they can make you do some of the cool things in there, sometimes it can be garbage in, garbage out. If you don't really know what you're doing in machine learning, you create a model that can be totally inaccurate. So you want to make sure you get the right people in there that can help you with those models. And then it comes, if I can create those models and do things with the data, and then to your question is kind of feed it back to the transactional system. So I can take that model, and if you think of somebody like Amazon, when you go to buy something, there's a machine learning model behind the scenes going, well, here's other stuff you may want to like. And dang it, I always seem to buy extra stuff at Amazon. They always seem to know what I want. And that's the machine learning model that's been trained based on what you've previously bought. And think of that as they move that machine learning model into their operational. And can you do that as a customer in your company in there? Can you be interacting with a customer and it pops up things like, well, maybe this person will like this, or maybe you should ask them about this type of loan if you're a bank. And maybe we're predicting that they're going to leave with a customer, and there's an 80% chance based on the historical trends of what we're tracking of the transactions, you should offer them some discount or coupon or something that went in their business. And so we see a lot of machine learning models trying to put that into the operational, so that the point of service in there where you can take actions right away and adjust behaviors of customers, as an example, to keep their business on there. So I would say that's even a more advanced, is to move that machine learning model into OLTP type of applications, but that's got its own challenges. But that's the beauty of creating machine learning models. You just need a lot of data to train it. Once you train it, you can deploy it and then pass in the variables from the OLTP systems and have instant results. So that's another big thing. That's a great thing to demo to customers, and they go, their mind just goes, "Oh, I didn't think we can do something like that. We definitely need to build this." And that's how you make them understand the value of it, and they're willing to unlock the budgets. And so it's interesting because we used to always talk to just the IT people, but they would do something like this as just another thing on their plate, and they may not be so high on doing it. But you do that to the end user, and they go, "This is going to make our life so much easier. This is going to allow us to save a lot more money, and we got a budget." And so they give that budget, and they get IT involved or hire more people. But it turns out that going to the end user was a lot more effective for making Microsoft, for making them understand the value than IT in a lot of cases.
Right. Thanks, James. You mentioned something interesting. You talked about Amazon propensity to buy model, which is like, okay, what would you buy based on your demographic, based on your prior buys and things like that? What are the 3 to 5 ML models that you're seeing in the industry that could be showcased? For example, churn, sentiment analytic. While we are talking about propensity to buy, we can also talk about propensity to pay, right? So based on that person's ability to buy, right? $100,000 versus $5, right? So what do you see the 3 to 5 models that you see as a showcase for the industry that they're trying to strive towards, but is still somewhere in between?
Yeah, there's so many models. A lot of it depends on the industry. And if you're a retail industry, if you're a health industry, and each one of those, I can go with dozens of models I've seen over the years to be very effective. And some ways it's kind of scary about what data is collected that you're not aware of. If you look at, say, the automotive industry, they can have IoT sensors on all your car, and they could go and predict that, hey, this is great. This is helpful for a driver to be able to have a message sent to them and say, we predict you're going to need not just an oil change, but your car tires are going to be replaced, or we're getting sensors from your engine. You need to go and have something like this checked out. Do it before it breaks. And imagine applying that to an airplane. We see a lot of machine learning models that predict the end of life or breakage of parts. And so you fix them before they break. Imagine that being in an elevator and having to fix something after hours that's broken on there. So that becomes very popular is the lifetime of individual parts. And so we're seeing more of the automotive industry try to build that in. Now, they also take that sensor data, and that could be used for help you with auto insurance rates on there, that you're more of a cautious driver in there. It could be used for, which was interesting in one case, where they took the data and they've got to the point where they said, you need service. Would you like us to schedule it to your nearest dealer because we know your location? We can do the appointments for you. And you can just go and get an email or text and say yes to everything. And then they collect that data of you driving, and then you go into the automobile dealer, and previously the salesman has got an alert that says, hey, we've analyzed all this data from this person and they like to drive fast. And so they may be interested in upgrading to a sports car. So when they walk in, go and talk to them about sports cars. So it's a way to upsell you on that. And that happens a lot. In the retail industry, they even have backdrops that will use cognitive services, which are the ability to sense your male or female, what your age is, and are you happy or sad, and adjust the backgrounds, the color schemes in retail shelving, because they know males are more attracted to certain colors. And then they highlight that they use those colors for the more expensive alcohol, for example, in the background, and the less expensive ones, they change the color so you're not as attracted to it. So there's all these, sometimes you feel like there's sneaky ways of using machine learning models to upsell you. And so a lot of that is trying to sell you products in there. But then some of the real value of machine learning models. You mentioned sentiment analytics, analysis in there. And I can pull in Twitter feeds and I can look across the country and find out spots where maybe a lot of people are catching the flu. And you can judge each of your Twitter feeds, whether this is sentiment, happy, sad, or neutral, and based on what you're looking for. What do they think of your company in there? And you can see maybe there's spots where you put in red where people all of a sudden have seen a lot of bad things about you and take actions on there. It could be that I'm a hospital or I should say a supply of medication, and I want to find out where I should disperse all this medication. And I see there's a lot of people talking about the flu in the Northeast, so I'm going to now move more of that to there. Maybe I can predict analytics on where we think the hurricane is going to be, and I can move, say, a Home Depot, and I can move all these supplies to different areas where we think there's going to be a hurricane, or there's going to be a lot of snow. Let's move this snow shovel up there. And so you don't have to be at the point again where you go to Home Depot and there's no snow shovel. Last thing that happened to me when I lived in the Northeast, and I go, why do they predict a model to know that there's a snow going to come and they have enough snow shovels there? And so I'm jumping around, but there's so many examples of it. And you can go online and you can look at like the Microsoft site, and you'll have my industry over machine learning models to give you some ideas. But they're becoming very popular as we have so much data that you can be collected. It's really unlimited in what you can do to help upsell or to save costs or to not have a depletion. I'll give you one more example. This was a company that sells cosmetics, one of the really big ones in there. And I didn't realize how much cosmetics they have to throw away. It was tens of millions of dollars every year because it has a shelf life. And so they were using machine learning to predict what areas would use this particular makeup. Maybe it was lipstick, and they know certain lipsticks are more popular in certain areas of the country. Let's get ahead of the curve, because if Kim Kardashian goes on there with certain lipstick, you know there's going to be a run on that supply in that part of the country. So they're using also machine learning to move the distribution around. It went all the way back to the manufacturing plant to say we need to increase or decrease the supply. And then if we have the supply around the country, let's move the supply before the expiration date, so we can sell more of this and not lose millions of dollars. And even if it was just a 5% increase in a decrease in material they have to throw away, that was still tens of millions of dollars in there. So that was one example where they were using machine learning to the extreme to save tons of money.
Thank you. James, where do you see, what are the industries which are technology laggard when it comes to the overall BI play versus the companies or verticals that are relatively advanced, right? From an overall positioning perspective, where do you see the hunger is to have this kind of AI ML play to advance their competitive differentiation?
By industry, and this is where a lot of companies like Microsoft has focused more on industry, and a lot of consulting companies have changed their model to be more industry focused on there, because you can then put people in place that know a lot about the industry, so they can talk about industry and about technology on there, so they can understand the latest trends. And because of that change in the last few years, I've seen a lot of the industries, almost really all of them, go to great lengths to start incorporating these technologies, these data warehouses, these machine learning and additional reporting on there. I think some of the laggards and I was in New York City, and there was a lot of finance, and they were somewhat of the laggards, finance, banking. A lot of it had to do with they were worried about the cloud and the security, and there had been a lot of education to make them realize that the cloud is more secure than anything you have on-prem. And the scale of these data centers that Microsoft has is much bigger than anything you have. And so it took them a while to have trust in the cloud. And then Microsoft has gone to the point where they have government cloud, and they even have these secret clouds that are used for military and such. And And so the level of security on there is just tremendous on there. So that the tools and technology are all there. And so finance and banking have sort of gone in the cloud, but they were behind the curve because it took them a while in there. And so I feel like that industry is still trying to catch up. And others ones, maybe small industries like the oil and gas are still behind. And a lot of that has to do with the cycle of oil prices and such. And the ones that I think are leading are like retail and healthcare, because they can see the value right away of how much money they can save. Or when it gets to healthcare, they can save a lot of lives on that. Just I kind of read machine learning that's predict when somebody is likely to be readmitted, which is the biggest cost, is they leave and they have to come back in there. So it's going to prevent that. So the machine learning model will say, we use these particular drugs, or keep them in the hospital longer, or look at other patients who had similar things and what they've done to prevent them from coming back. So they see the hospital is kind of like a double win. They see a huge way to save costs, but also a huge way to save lives. So I always felt the healthcare was more in the leading, and then the retail, because even saving a few pennies here and there because of the volume in there, they can be many millions of dollars in there. And so I mean that's my take on it. It's based on my own personal experiences of working with a lot of different industries.
You mentioned healthcare. So I've been working with a company around fraud, waste, and abuse within the healthcare. So billing, Medicare, medical billing, right? There's a lot of abuse happens there. Do you see companies or healthcare organization adopting these kind of models, and what is the level of maturity there? Because one use case I have seen where, with Medicare, just one billing organization, Medical Network, it was $90 million worth of abuse, fraud, and waste that has emerged within 1 or 2 weeks of modeling, right? It could be much bigger than that. So do you see that use case happening in healthcare based on your experience, and what is the maturity level there?
Yeah, that's a good point, because now I'm having flashbacks. And one of the first machine learning models I did was just that. And that must have been 7, 8 years ago, was to find fraud. And there was a lot of it being double billed, or billed for services that never happened, whether it's a patient doing it or a doctor doing it. And to your same point, I remember them saving tens of millions of dollars by being able to find claims that should be declined because of machine learning model, and tell them, look, this is very similar to something else. And then, there's all this, machine learning models are great because you can have this accuracy. Like we think there's 90% chance this is a duplicate, and then maybe a duplicate claim, and then maybe we automatically reject something that's say 80% or higher. And then if it's in say the 50 to 80% range, we're going to have somebody manually look at it. And then 50% or lower, we're going to say, well, it's no. Whatever those numbers are, it's greatly saving on the time and expense of people manually looking at everything, or just kind of spot checking things like that. So the machine learning models in that capacity can save tons of that. So yeah, that's a big thing is fraud. And same with the banking industry now. And there's these products, and UI has some of them that can detect fraud through looking at banking transactions. They use machine learning for that. They can detect, hey, we think there's money laundering going on, by analyzing that data and having machine learning models off of that. So that's something that can save with very little effort, really, just having the data, tens of millions of dollars. But the healthcare industry was just more at the forefront because it seemed to be a little bit simpler in the models you can create based on the data. It was almost like a no-brainer. Oh yeah, let's look for duplicate claims, and that's pretty easy to do because machine learning models, that this is what they're thrive on is finding duplication of things like that, and you just have the right data scientists in there that build that model and tweak it a little bit, and man, the level of savings and reduction of effort finding fraud is tremendous.
Right. No, thank you. How do you see RPA playing a role in larger business intelligence? Like, I mean, there are so many robotic processing is happening with respect to billing, customer care, and others. Do you see them playing a role in modern BI?
Say that question again.
The RPA, robotic processing for billing, claims, customer service, and all. Do you see them playing a role in the modern BI, like, bringing the data? Because like you're trying to cut the cost of resourcing, right? By implementing this robotic processing. How do you see playing a role in the modern BI?
Yeah, it's interesting too because the tools have gotten better. They allow some users to do some of the things that were typically done with IT on there. So the users in there, and the whole idea when I talk to customers about building solutions is make it so you can do self-service BI. So I could do the upfront work and have the data presented to them so they can go to something like Power BI and just click and drag fields over there. So this is where you get into, if I just dump it all in a data lake and I tell somebody to go use Hive and Spark SQL, you may feel an end user who just doesn't even understand any of the words coming in their mouth on there. So somebody from IT needs to go and do the upfront work and put it in a relational database with the metadata, create a star schema, and so they're doing all the joining so they don't need to do all that and clean all the data and master it all. And then you go, here's a Power BI data set, click on that, here's all the fields, go have at it. And they go, oh my God, this is so easy. And they drag the fields over. And they can even maybe create machine learning models from that. But you've made it so easy. So that's where I would say, when I look at this modern data warehouse or data fabric and the data is being copied and they go, well, it's too expensive. And I got to make these multiple copies. I go, but as the data moves along here, you're adding more value to the data. You're making it easier for the end user. So yeah, I copy it from data lake to relational database, and then I maybe create a star schema out of it. And it's multiple copies, but the end result is, oh, it's so easy for an end user to who may be a mechanic on a service line who doesn't know anything about technology, but you present them to them with very little training, they can start creating those dashboards and those reports on there. So it's that balance of it. And that's why I think data lakes failed, because they didn't understand that the people using this have no understanding of the technology, and you made it too hard for them, because a data lake is just a glorified file folder. And you just throw files in there and people are gonna be like, I don't know how to make sense out of this in there. So do that extra work on there. And so this is where we're seeing a lot of the responsibilities now of generating reports and dashboards are the end users, and not waiting for IT to go and build it, because IT did the work and creating an environment where the end users and all these different various organizations within the company can build the data, build the reports and dashboards on their own.
Thank you, James. I want to wrap up this conversation. So thank you, James, for the great insight. Again, for a larger audience here, if you're seeking support in terms of any data management and analytics project in the cloud, Sexton Global is the company to call upon. We'd love to support you. And thank you again for joining.
Yep. And thank you for having me on the show. I love talking about this technology, and hopefully I helped clarify some things.
Yeah, absolutely you did, James. Thank you.